So actually the name of the thing was wrong, and I had submitted the correct name, but so actually not open source, but we're bioprinting with multimedia curriculum. So the problem is that early STEM education is, it's improving, but we actually are kind of behind compared to other countries with respect to biology in the STEM especially. So one of the solutions that we're proposing is to educate people a lot younger in terms of, introduction to stem cells and other kinds of other cells with cell culture and bacteria. So one of the ways that we're thinking of doing this is through introducing bioprinters, which are a very new technology. Schools are actually starting to introduce regular 3D printers, but not anything for biology. So this is something that we know how to develop and that we're thinking of introducing. One of the other issues are that students need to be able to be proficient in this because this is something that they're going to have to use in the future and be proficient in, like with microscopy, if they're going to be going into biological sciences. The opportunity, so there's actually 98,000 public schools in the United States alone. So there's also about 50 million students that would be subject to this early STEM education that would be using this product. That's about 3.1 million professors or teachers. So in the Merrimack Valley alone, there's about 10 public schools that we know of that would be interested in using this product. In addition to UMass Lowell, I spoke with Dr. Nugent, even though this is actually, we're proposing it for earlier STEM education, but it can be used for older researchers as well. And the industry is expected to grow by 21% by 2022. In addition to that, there's supposed to be a $581 billion industry market shares alone globally, and about $1.8 billion in the US. So, in terms of actual competitors, there really aren't any competitors that are doing what we want to do, that want to provide curriculum and multimedia lessons to learn how to use it. So there's really not competitors, but there is one company which is called Seed, or C3D. So that's not really a competitor, but that's someone that is able to produce what we have. So the solution that we're proposing is that we are going to be producing very cost-effective bioprinters, probably around the $4K range, $4,000, and we would be producing with that multimedia curriculum as a package via subscription for approximately between $100 to $260 per year fee. And this sort of thing is, it's well known to be able to have, educational supplements online for like teaching in terms of how to use the technology, or in terms of cell culture, what kind of cells you can understand histology in terms of what the cells look like and things like that. Teachers and educators would be able to provide homework assignments, if they should so please, for things like different components of the bioprinter, how to use them effectively, what sorts of things they can use, what applications they would have in the field later, and things like that. In addition to that, we would be providing reagents guides, which no one else has done for this population before. So if you don't know how to use the bioprinter, you don't know what kinds of reagents or hydrogels or cell lines you want to use, we'd be able to provide both the cell lines for that and all of the substrates, as well as tell them what they would need, and have the bioprinter be easy to use and user-friendly so that you can just have preloaded experiments, just choose on a touchscreen what you want to use, and it would know what temperature and pressure to set that to be able to extrude. And we know how to do this already. In addition to that, we would be able to have optional, additional subscribing components to that, at which they could subscribe to other reagents that aren't necessarily provided with that as a total price. Resources, so we would need about $5,000 or $4,000 to be able to get a lab space, a working space. We would need like an area to do cell culture and test our product and build our prototype and rent the lab area. In addition to that, we would need like a little bit of information in terms of reagents and things like that, which I pretty much already know, but not all of our team does. So yeah, that would be from difference maker funding, and we would be developing the curriculum ourselves. Thank you. Do you have questions?